Fuck. I just did all of that and the mute button wasn't on. Alright, well, we start again. Explain how to find the factorial of a number. The factorial is a function that can be performed on any non-negative integer. It is represented by the exclamation mark sign, written after the integer on which it is being performed. The factorial of the integer is the product of all positive integers less than or equal to the number. For example, 4 factorial, read 4 factorial, is calculated as 4 times 3 times 2 times 1 equals 24. Because 4 times 3 equals 12, 12 times 2 equals 24, 24 times 1 equals 24. Since 0 is not itself a positive integer, not does it have any positive integers less than it. 0 factorial cannot be calculated using this method. Instead, 0 factorial is defined by the conversion to equal 1. This makes sense if you consider the pattern of descending factorials. 5 factorial equals 120. 4 factorial equals 24. 3 factorial equals 6. 2 factorial equals 2. 1 factorial equals 1. And 0 factorial equals 1. Because 0 factorial over 1 equals 1 over 1 in 1. Note, you will see this reasoning in exponents, where if something is to the power of 0, it is equal to 1. Next, define permutations. For any given set of data, the individual element in the set may be arranged in different groups containing different numbers of elements arranged in different orders. For example, given the set of integers from 1 to 3, including the elements of the set are 1, 2, and 3, written as 1, 2, 3, they may be arranged as follows: 1, 2, 3, 12, 21, 13, 31, 23, 32, 123, 132, 213, 231, 312, 321. These ordered sequences of elements from the given set of data are called permutations. It is important to note that permutations, the order of the elements in the sequence, is important. Very important. Remember that. Muy important. The sequence 123 is not the same as the sequence of 213. Also, no element in the given set may be used more times as an element in a permutation than it appears as an element in the original set. For example, 223 is not a permutation from the set above. For example, because the 2 appears twice, more than given in the set. And there is a terrible permutation formula. N capital P R equals in the numerator n factorial, end of numerator passing the verliculum to the denominator, start of parentheses n minus r, end of parentheses factorial. Next, explain how to find the number of permutations of a given set. To find the number of permutations of r items from a set of n items, use the formula n capital P R equals in the numerator n factorial, end of numerator going past the verliculum or the fraction bar into the denominator, start of parentheses n minus r, end of parentheses factorial. Another terrible drawing of the formula. When using this formula, each element of R must be unique. There must be one of it. Uno. This assumes the different arrangements of the same set of elements yields different outcomes. For example, 123 is not the same as 321. Order is important. Cannot say that enough. Order is important. A special case arises when finding the number of possible permutations of n items from a set of n items. Because n equals r, the equation for the number of permutations, because simply p equals n factorial, a set of n items, because n equals r, the equation for the number of permutations becomes simply p equals n factorial. The same result is true for r equals n minus 1. Both of these cases are a result of the fact that 0 factorial and 1 factorial are both equal to 1. If a set contains one or more groups of indistinguibles or interchangeable elements, i.e., IG, I guess, that set, example 1, 2, 3, 3, which has a group of two indistinguibles threes, there is a different formula for finding distinct permutations of all n elements. Use the formula p equals in the numerator n factorial, end of the numerator crossing the verticulum into the denominator, m1 factorial, m2 factorial, mk factorial, where p is the number of permutations, n is the total number of elements in the set, and m1 through mk are the number of identical elements in each group. E.g., for the set 1, 1, 2, 2, 2, 3, 3, m1 equals 2, m2 equals 3, and m3 equals 1. It is important to note that each repeated number is counted as its own element. For this purpose of defining a, e.g., for the set 1, 1, 2, 2, 2, 2, 3, 3, n equals 7, note 3. End of that. Page 71 in my notebook. Explain how to find all possible permutations of a set of unique items. Page 77. To find the number of possible permutations of any number of elements in a set of unique elements, you must apply the permutation formula multiple times. For example, to find the total number of possible permutations of the set 1, 2, 3, first apply the permutation formula for situations where n equals r as follows: p equals n factorial equals 3 factorial equals 6. This gives the number of permutations of the three elements, where all three elements are used to find the number of permutations of the three elements, wherein all three elements are used to find the number of permutations when only two of the three elements are used. Use the formula n capital P r equals in the numerator n factorial, end of numerator, passing the verticulum or the fraction bar into the denominator, start of parentheses, n minus r, end of parentheses, factorial, where n is 3 and r is 2, n capital P r equals n factorial, still in the numerator, passing the virgulum down below south to the denominator. Start a parentheses n minus r, end of parentheses, factorial equals 3p 2 equals 3 factorial. In the numerator, passing the virgulum or the fraction bar into the denominator, start a parentheses, 3 minus 2 parentheses factorial equals 6 over 1, which equals 6. To find the number of permutations when one element used, use the formula n capital P r equals, in the numerator, n factorial, going south past the virgulum or fraction bar into the denominator, start a parentheses, n minus r, end of parentheses, factorial, where n is the 3 and r is the 1, n p r equals, in the numerator, n factorial, going south past the virgulum or fraction bar into the denominator, start a parentheses, n minus r, end of parentheses, factorial equals 3p1 equals 3 factorial, in the numerator, past the denominator, into a denominator, 3 minus 1, end of parentheses, factorial equals, in the numerator, 3 factorial over 2 factorial equals 6 over 2, which is divided into 3. Find the sum of the three formulas. 6 plus 3 equals 15. Total possible permutations can be written as follows. I haven't written the formula and I didn't think I would get this far, but it's PT equals the summation weird big E thing, n I equals 1, in the numerator, n factorial, end of numerator, going south past the verticulum or fraction bar into the denominator, start a parentheses, I minus 1, end of parentheses, factorial. I will write it again. Next we're going to do combinations. In this video, after I realized I was recording the sound, explain how to find the factorial of the numbers, explain how to find permutations, and then explain how to find all possible permutations of a set of unique items. And there's something else I think I did. Yes. Oh, heard. Anyways, have fun, stay out of trouble, and so on.